right, today starts part 1 of 14.7, operations and scientific notation. Do you know what the word operations means when it comes to math? Anybody know? It's a fancy word. Yes, there are 4 primary. Oh, there's another big word. What does primary mean? Main. Okay, there are 4 main operations in math: addition, subtraction, multiplication, and division. So we're going to look at all 4 of those operations today and tomorrow in 14.7. Okay, so here's some important information. I actually forgot to put the blanks in, so just underline them as if it was a blank. You cannot add or subtract in scientific notation unless the exponents are the same. So I like to compare this to a fraction. Okay, so 2/3 plus 5/6. All right, now in a fraction, I cannot add these together, right, without a common denominator. Would you agree? Yes. So the same rule applies for scientific notation. I cannot add numbers in scientific notation unless my exponents are the same, like a common denominator. All right, we don't even need to worry about solving that. I just wanted to kind of draw a comparison. All right, now, did I say anything about multiplication and division? No. And just like multiplying and dividing fractions, do I need an LCD? No. And I don't need a common exponent for multiplication and division either. It's only addition and subtraction. All right, Gabe?
Sorry, but I have no idea how to find it. 14.7.
Okay, no worries. I'll get it. I'll get you one in just a sec. All right, now, next point. To increase the exponent value, you're going to see a little bit of this today and probably a little bit more, or maybe just a different angle of this tomorrow. But sometimes you have to increase or decrease an exponent value, and that has everything to do with moving that decimal. So what my rule says is if I need to increase it, say from 10 to the 3rd power to 10 to the 4th power, I will move my decimal left, so underline that, in the number being multiplied. That's what I see in the example. It's 2.3 times 10 to the 3rd, but if I need to raise that exponent, I'm going to move my decimal to the left and make it 0.23. All right, so the reverse is true too. If I need to move my decimal to the right, what's going to happen to my exponent value? It's going to go down, okay? If I move my decimal left, my exponent goes up. If I move my decimal right, my exponent goes down. That is that is the most confusing part of this lesson. Okay, so hopefully we can work through that and it will become less confusing to you. But it's not going to be less confusing until we do some practice. Okay? Example 1. All right, so the title of the example gives it away. We're adding and subtracting. However, if the title wasn't there, what in the expression actually tells me the operation? Because there's multiplication here and there's multiplication here. So how do I know that it's addition?
Because there's an addition sign in between.
So you have to look, okay? Because imagine, guys, on your quiz, it's all going to be together in the same section. So how do you know which one's addition, subtraction, multiplication, division? It's the sign between the 2 sets of numbers, okay? So you see addition in the first one. What do you see in the second one? Subtraction, okay? So that's what tells you the operation. Because it's addition and subtraction, I must check my exponents first. Do I have the same exponent?
Yes.
That's like a common denominator. Because I have the same exponent, I can now combine my decimal values according to the operation that's connecting them. So because there's addition, I'm going to add my decimals together. I must use my decimal rules. Line up your decimal. Okay, just like adding decimals. All right, 0, little placeholder, and add your decimal values together. Okay, did you guys get 13.32?
Yes, ma'am.
Okay, That's great. So my rule says I add my decimals together and bring down the common exponent that they both share. Do not add those exponents together. It's like adding fractions. You don't add the denominators together either when you're adding fractions. Just bring down the common exponent. But this is not my final answer.
I promise you if you make us multiply.
You don't have to multiply it. It's not in scientific notation. Why? The number's too big. The number's too big. So what do I have to do to my decimal to get my number in the range of scientific notation? Yes. Does anybody remember what we just said in the last slide? Yes. If I move my decimal left one place, my exponent goes up by the same number, by 1. Okay, so it's 1.332 times 10 to the 4th. 10 to the 4th power. You don't have to multiply it. I know Miles was worried I was going to make you multiply it. You don't have to multiply it. Okay? All right. Okay, so now I want you to do the second one. And can I just let you on a little hint, okay? For the subtraction, you're never going to have a number that's greater than 10 after you subtract. Because those numbers are already in scientific notation. However, it could be less than 1. And then it would go the other way, okay? But that's not going to happen here. Go ahead and simplify and remember, keep your common exponent. All right, so 7.8 minus 4.5. Don't you love it when you subtract and you don't have to carry?
Yeah. Oh, yeah.
All right, you just bring them down. 3.3 times 10 to the negative 5th. Miles, do I need to do anything else to this problem? No, I don't, because my number is in the correct range. It's greater than 1 and less than 10, so I'm good. I am done with that problem. All right, questions? Okay, let's move on. All right, so pretending again that we don't know what the title of this example is, which sign do I look for to know the operation I'm dealing with? The one in the middle between the two sets is multiplication. So now I'm going to go by a whole different set of rules. Okay? Multiplication all the way across. Do you agree that every term in this entire expression is being multiplied?
Yes.
There's no other operation.
Right.
So when that happens, I can use commutative property of multiplication. Does anybody remember what commutative property means?
Yes.
I can change the order. I can switch them around however I want. Would you agree? I can multiply 4 times 5 and 5 times 4. It's the same answer. Okay, so commutative property, guys, tells me that I can group 3 times 5 together. And I can multiply that, and I can multiply my powers of 10 together. Okay? All right, because it's all multiplication, I can do this. So what is 3 times 5? 15. Oh my goodness, I don't want to have to multiply all these negative 5th power and all that, but wait, do I have the same base? So, same base, I can use product of powers. Yes, 10 to the negative 5th power plus negative 2. I can combine the exponents because I have a common base. What's negative 5 plus negative 2? Negative 7. Don't worry that it's a negative exponent. I know when we see a negative exponent, we're like, oh, I can't have that in my answer. I've trained you well, but we can keep scientific notation negative. All right, so 10 to the negative 7th power. However, this is not my final answer. Zach, why isn't it my final answer? Yes, the number's too big. So, which way do I move my decimal, class?
Left.
To the left. All right. What's going to happen to that exponent?
It's going to go down to 6. It's going to go up to 8. It's going to go to 6.
Yes. Okay. Yes, you guys are so enthusiastic today, and that's great. Because it's negative, when I increase the value of a negative, it's getting closer to 0, which means it's -6. Yay, you guys are great. Okay, I'm so proud of you. All right, awesome. Now do the next one. Can I also drop you another hint, and this might be helpful to write. Most of the time when you multiply, your number is going to be bigger than 10. How many numbers could you multiply that would be less than 10? Not that many. Yeah, well, 5 times 1, 2 times 2, 3 times 3. But there's not a whole lot, okay? There's not a whole lot. All right, so sometimes you are going to have that. Okay, so you say no, and I'm going. All right, 12 times 6. And 10 to the 4th times 10 to the 8th. Okay, so I group my numbers and I group my powers of 10. What's 12 times 6? 72 times 10 to the 12th power. All right, final answer? No. What is it? Say it with me. 7.2 times 10 to the 13th power. Awesome, great job. All right, so that's multiplication. So you might even be able to kind of assume what we're going to be doing with division. All right, we're using quotient of powers now with our powers of 10, and we're dividing the decimal values. Now, don't worry, you're not going to have this extremely long division problem, but you do have to do some long division because you don't have a calculator. All right, so remember, it's the numerator divided by the denominator. Okay, 6 does not go into 1, so a 0. 6 goes into 18 3 times. Not too painful. Okay, I have my decimal value done. Now I need to simplify my powers of 10. Okay, be very careful, guys. You're going to have double negatives in here. It's in your homework. But maybe not on this problem. So 10 to the 8th power, -8, minus 7. Remember, remember we always subtract numerator minus denominator. All right, so that equals, let's put it together now. 0.3 times 10 to the -15th power.
More than one. Oh my gosh, why am I such a genius?
Okay, so now, now I've got the other way, the other problem. Now, yes, it's too little. Which way do I need to move my decimal? To the right. So if I move, if I move my decimal to the right, my exponent goes down. Yes. Okay, so now it's 3. You could say 3.0 times 10 to the -16th power. All right. Let's go ahead and do the last one quickly-ish. Okay, let's go ahead and do the last one. It's just a different format, and I think this is the format that's in your homework. We'll do this last one, and then we'll be done. All right, so 1.5 is on the inside. 7.5 is on the outside. Well, I can't have a decimal, but does everybody agree I'm moving it 1 here and 1 here, so they just kind of cancel out? Okay, so I'm just going to erase them. But 75 doesn't go into 15. Okay, so I got a 0, and then my decimal, and then, well, not the decimal there, but, yeah, and so 75 goes into 150 how many times? 2, okay. Now I'm going to do my powers of 10. 10 to the -3rd power minus 2. I always do the first one minus the second one. What's -3 minus 2? -5. All right, so 0.2 times 10 to the -5th power. Is that my final answer? No. No, I have to move it right. So 2 times 10 to the -6th power. Move it right. My exponent goes down 1 value. All right, guys, that's it for day 1. Good job.